All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about Dalton's law of partial pressure. And he stated that the total pressure exerted by a mixture of gases which do not react chemically together, please note that point, which do not react chemically together, is equal to the sum of the partial pressure of the gases that's made up of the mixture. Okay? You need to note that force of attraction do not exist between gases which do not react chemically together. Okay, since they do not react chemically together, there is no force of attraction between them. In other words, force of attraction do not exist between gases in Dalton's law of partial pressure. Full stop. Now, right, the temperature and volume of gases in Dalton's law of partial pressure are the same. Okay, so the only thing that differs is the number of moles. In other words, number of mole is the only factor affecting Dalton's law of partial pressure. So mathematically, we have that the pressure total pressure is equal to the what? The sum of the other pressure that makes up. Let me say this is pressure, the first pressure, the second pressure, the third pressure, plus. So that is just that. Right? Note, when a gas is collected, and all these P1, P2 are just pressure for gas S, okay? Pressure for gas Y, pressure of gas Z. All right, note, when a gas is collected over water, note, very important, when a gas is collected over water, the gas is usually saturated with water vapor. With what? Water vapor. Okay, that is, therefore, the total pressure of a gas becomes, the total pressure of the gas becomes T total is equal to what? Pressure of that gas plus pressure of water. This is a very important formula to note. All right. So then pressure of dry gas, pressure, or let's call it pressure of dry gas, the dry one, the dry gas. Okay. So to get the pressure of dry gas, which they will ask you, pressure of dry gas is equal to what? The total pressure minus pressure of water. Very important formula to note. All right. Okay, so let's continue. From ideal, can I clean here? Yes, from ideal gas equation, we know that PV is equal to what? nRT, right? Then therefore pressure is equal to nRT over volume. Okay, we know that. Then this one means that to get the pressure of this, don't forget that Px is equal to what? Nx Rx Tx over what? Vx, to get P of y, which is what? Ny Ry Ty over what? Vy. Right? To get the pressure of Z is equal to what? Nz Rz Tz over what? Vz. All right? Now, you should know that what? R is what? Gas constant, gas volume constant. Then, and remember that we say that what? That in Dalton's law of partial pressure, that the volume and temperature remain constant. So if the volume and temperature remain constant, the only thing that is left here is that Px is equal to what? Nx. These ones will now remain constant. They are the same thing. Okay? If they are the same thing, we are going to have, well, let me put it, carry this thing and put in our equation. In our equation, permit me to clean here. If we put it, we have that P total. We will now have that P total will now be equal to what? We got this one as what? Nx Rx Tx over what? Vx plus Ny Ry Ty over Vy plus Nz Rz Tz over Vz. But we say that what? That the temperature and pressure remain constant. And don't forget that the number of mole will remain constant as well. So they are the same thing. So what do I have here? The only thing that is different, let me bring the ones that are constant, that are the same. So that is factorize the same thing. All these things are the same. Let me just call it R T over V. These ones are the same. The only thing that is not the same is what? My Nx plus Ny plus Nz plus dot dot dot, because it continues. Okay, so that is very, very important formula to note. That is a very, very important formula to know, that P total is equal to this. Very, very important formula to note. And then you need to know that what? That N total, in fact, if you say N total from here, N total, then the same RT over V is equal to what? RT over V in bracket of Nx plus Ny plus Nz plus dot dot dot. So if this cancel this, we now note that N total is equal to Nx plus Ny plus Nz plus dot dot dot. So this is another important formula to note. All right, this is another important formula to note. So that is that. All right, so can I clean here? Yes. All right, so another thing you need to note, don't worry, when we'll be solving calculation, you understand perfectly. Okay, another thing you need to note is that if you want to get P of x simply mean N of x all over N of x, in fact N total all over N total times the total pressure, P total. Please, this is another formula that is very powerful. So to get P of y should be what? N of y all over what? N total times what? P total. Okay, to get P of z should be what? N of z all over what? N total times what? P total. All right, so these are important formulas to note. These are important formulas to note. Now, another way we can do that is okay. But if the question is given in volume, sometimes they can give you the question in volume. So if the question is given in volume, sometimes they will just give you the question in volume. Just change everywhere to volume. You have that what? P of x should be what? The volume of x all over what? The total volume times the total pressure times P total. The same thing, P of y will now be what? Volume of y, sorry, all over the total volume times total pressure. And then P of z will now be what? Volume of z all over V total times P total. All right, so that is that. So we are going to be solving calculations to illustrate that. We are going to be solving calculations to illustrate that. So the first question we are going to solve, the first question said, if number one said, if a vessel contains 30 cm cube of nitrogen at a pressure of 110 millimeter mercury and 20 cm cube of oxygen at a pressure of 230 millimeter mercury. All right, calculate the partial pressure of each calculate the partial pressure of each of nitrogen and oxygen. Each of nitrogen and oxygen. Okay, so what do we do? Can we get the total pressure? Yes, we can get the total pressure. And the total pressure is gotten by solution. We know that total pressure is equal to what? The pressure of nitrogen plus the pressure of what? Oxygen. So what do we have? The pressure of nitrogen is 110 plus the pressure of oxygen 230. So both of them will give me 340 millimeter mercury. All right. So now to get this, since they gave me in volume, don't forget this formula. This formula is very, very important. They gave me volumes. So we know that the volume of nitrogen is equal to what? 30 cm cube. And the volume of oxygen is equal to what? 20 cm cube. So their partial pressure, P of volume, P of nitrogen will now be what? Volume of nitrogen all over what? The total volume. The total volume times the total pressure. All right. So we can get that the total volume should be the volume of both of them. So what do I have? Let me get the total volume. So V total will be equal to what? 20 plus 30, which is equal to what? 50 cm cube. Okay. So from here, I'll have that what? 30 over 50 times, I've gotten this one as what? 340 over 1. So what do we have? 30 over 50 times 340 over 1. So what do we do? Okay. So 30 divided by 50. That is 0.6 then times 340. I have 204. All right. So I'm having what? 204 millimeter mercury. Okay. They gave us the pressure of nitrogen. Pressure of nitrogen. Oh, sorry. That thing is not total pressure, please. That formula I gave is very wrong. The formula is, if it is given in volume, please, if it's given in volume, it is what? P of x is equal to what? The partial pressure is equal to V of x over V total times pressure of x. Okay. So use the same thing for y and z. So if we now use it here, we now have that what? That the pressure of nitrogen, the partial pressure of nitrogen, okay, partial pressure of nitrogen will now be 30 over the total is 50 times the pressure of nitrogen is 110. So what do we have? We will have 92 millimeter mercury. All right. So the pressure of oxygen will now be what? 20 over 50 times, they gave us pressure of nitrogen, which is 230 over 1. So we will have that okay. So I have 20, that is 92 as well. 92 millimeter mercury. So sorry for that formula. So that is that. Okay. So the B said the total pressure of the mixture. Okay. I did not write the second one, the total pressure of the mixture. So that the total pressure of the mixture will now be, so I don't need this. The total pressure of the mixture will now be the two partial pressure we got. So that is partial pressure of nitrogen plus partial pressure of what did we get in the other one? When you do this, sorry, 30 divided by 50. 30. Okay, 138. This is 138 millimeter mercury. All right. So I have so the total pressure will now be what? 138 plus 92. So the total pressure plus 92. So I have 230 millimeter mercury. Right? So that is 230 millimeter mercury. Okay? Thirty divided by times 110. Am I making mistakes somewhere? 30 times 110 divided by 50. Oh, this is 66. 66 millimeter mercury. So I have 66 plus 92. 66 plus 92. That is 156. 156 millimeter mercury. Okay. Okay. So let's solve the second question. For the second question, I have 40, number 2, 40 cm cube of a gas was collected over water. Okay, at 8 degrees Celsius and 689 millimeter mercury. Okay, then I say calculate the volume of the dry gas. Calculate the volume of the dry gas at STP. Okay, at SVP, saturated vapor pressure at SVP. Okay. Okay, at STP. You want to say if the saturated vapor pressure, if the saturated vapor pressure of the gas at 8 degrees Celsius is 9.33 millimeter mercury. Okay. Okay, solution. They said that we should calculate what? Calculate the volume. We need to calculate the volume, but before that, we know that total pressure is equal to pressure of the dry gas plus pressure of water or vapor pressure. Pressure of water or vapor pressure. Anyone. All right? Vapor pressure. Vapor. You know, vapor is same thing as water. Vapor pressure. Okay? So now we have that uh, 40 cm cube of gas was collected over water at 860. This is the total. So I have 689 is equal to what? Pressure of the dry gas that I don't know. Plus, this one gave me 9.33. So therefore, pressure of the dry gas is equal to 689 minus 9.33. So what do I have? I have 679.67 millimeter mercury. Okay? So they are not asking us to calculate the volume. They're asking us to calculate the volume. So, which means our P1 is this thing we just got now. Okay? We just got our P1 as 679.67, and our V1, the first volume given, is 40 cm cube. 40 cm cube. Okay? So, what is our P2? So, the temperature they gave us, they said that the temperature is constant, but they said as standard temperature and pressure STP. So a standard temperature and pressure. So which means our T1 is 8 degrees Celsius, which is what? 8 plus 273, which is 8 plus 273 is 281 Kelvin. Okay, a standard temperature and pressure, that is STP. A standard temperature and pressure, standard temperature T2 will be 273 Kelvin. Okay, standard temperature and pressure, standard pressure P2 is what? Since it is millimeter mercury is 760 millimeter mercury. All right, so I know that V1 P1 over T1 is equal to V2 P2 over T2. So once you know this thing, you can cross multiply to get your calculate the what? The volume. So the V2 is unknown. So therefore my V2 will now be what? V1 P1 T2 all over what? T1 P2. So if you do that, substitute everybody to have 40 times 679.67 times 273 divided by 273. Sorry, 281 times 760. So if you do everything, you are getting 34.7 cm cube. 34.7 cm cube. So that is that for that. Right? So the next question. Okay. So the next question said a mixture of three gases CO2, SO2 and O2 has a total pressure of 38.2 atm, they now said the partial pressure of SO2 and O2 are respectively 12.2 atm and 17.5 atm. They now say calculate the pressure of CO2. Okay, this is very, very simple. So just say solution, the total pressure P total pressure is equal to pressure of CO2 plus pressure of SO2 plus pressure of O2. So the total pressure is what? 38.2 is equal to what? Pressure of SO4. The second, we don't know this one. Pressure of CO2 plus the other one gave us 12.2 plus 17.5. So therefore, pressure of CO2 is equal to 38.2 minus 12.2 minus 17.5. So if you do that, you will get 8.5 atm. Okay, so that is that. We keep solving. These things are very, very simple. So let's take the next question. The next question here said hydrogen hydrogen was collected over water. Hydrogen was collected over water at 21 degrees Celsius on a day when the temperature was 748 Kelvin. Sorry, when the atmospheric pressure, when the atmospheric pressure, when the atmospheric pressure is, when the atmospheric pressure was 748 millimeter mercury. Okay, they now said the volume, the volume the volume of the gas collected was 300 cm cube. Okay, they now said the standard vapor pressure of water H2O at that 21 degrees Celsius is 19 millimeter mercury. Okay, they now said a how many mole how many moles of hydrogen, how many moles of hydrogen were present. B, how many mole of water vapor is present in the mixture of the gases. Okay, how many mole of water vapor were present in the mixture. Okay, so this is a very simple question. So let us get the things that we need. So solution. First of all, they say that hydrogen was collected over water at the temperature they collected it was 21 degrees Celsius, which is 21 plus 273, which is 21 plus 273 will give you 294 Kelvin. Okay, on a day when the atmospheric pressure was this, that is the total atmospheric pressure they gave us, the total atmospheric pressure was 748 millimeter mercury. Okay, then I said the volume of the gas collected, is 300 cm cube. Okay, then I said that the vapor pressure of water is the vapor pressure, which is what, 19 millimeter mercury. Okay, but I know that P total is equal to pressure of the dry gas, that is pressure of hydrogen, plus pressure of water. All right, so total pressure is what, 748 is equal to pressure of hydrogen that I don't know, plus pressure of water is 19. So pressure of hydrogen will now be 748 minus 19, which will give you 729 millimeter mercury. Okay, so since we have gotten this, they say we should calculate the number of mole. The number of mole is unknown, but I know that my PV is equal to nRT. Don't forget that. So my number of mole is equal to PV over what, RT. So which is what, my P is what, the P is the pressure of the hydrogen gas. That is what we are looking for. That is the number of moles of the hydrogen gas. So we are using this, which is what, 729 times the volume at that point is 300, times 300 divided by what? Don't forget that your R is always 0.082 times the temperature there. The temperature at that time is 294. So if you do everything there, you are going to get that the volume is the volume will give us 0. Okay, but the volume is supposed to be in dm cube for us to use this. Please don't forget, this should be 300 divided by 1000, which is 0.3. Okay, so I'm going to use 0.3 here. So 0.3, because it must be in dm cube for an ideal gas. So if you do that, you're going to have that this is for hydrogen. So will now be what? 1.19 times 10 raised to power minus 2 mole. Okay, so that is that. Now they're not asking how many mole of water, we are collected. So permit me to clean here. I have gotten this one. So the number of mole of water that we are collected should be equal to what? Number of mole of water. Okay, we're going to use the pressure of water. The pressure of water as at that time is 19. But is the pressure not supposed to be in the pressure is supposed to be in atm? So we made mistake. The pressure here is supposed to be in atm, sorry. So let me recalculate this, please. So we're supposed to put the pressure in atm. So pressure of hydrogen is supposed to be millimeter mercury is 760. So 729 divided by 760. To put it in atm, that is 0.9592 atm. Please, very very important. So we know that our pv is equal to nRT. So our n will now be what? pv over what? RT. So please always remember that in an ideal gas equation, your pressure must be in atm and your volume must be in dm cube. Your temperature must be in Kelvin. So please always remember that. Don't forget. So this one will now be now 0.9592 times the volume there is 0.3. Now divided by what? 0.08 is my ideal gas times the temperature as at that time is 294. So if you do everything now, that is when you will now get that 1.19 times 10 raised power minus 2. Okay, so that is that. So your assignment is to calculate this one. So you are going to use the pressure of water. So that is a standard vapor pressure, which is this. You have to convert it to atm. So and it's at the same temperature. So this is the volume, this is the pressure, this is the temperature. We know our R is always there. So the volume there, the volume of water. How do we calculate the volume of gas collected was this? So what about the volume of water? So how do we calculate the volume of water? It's an assignment. You can look into it. So if you didn't get that, you let me know. Then I can now find the solution. I'll do a video on the solution to that. So that is that. So the next question, let me check my time. Okay. Okay, the next question said, let me solve about 2 more questions, and then they said a mixture of 0.2 mole of argon, comma 0.2 mole of nitrogen, 0.2 mole of nitrogen, 0.2 mole of nitrogen, and 0.2 mole of helium, and 0.3 mole of helium. Okay, exert a total pressure of 2.10 atm. Then I say calculate the partial pressure of nitrogen in the mixture. Okay, so you should know that what the partial pressure of nitrogen is equal to what? The number of mole of nitrogen all over the total number of mole, okay, times the total pressure. Okay, so we have that the number of mole of nitrogen 0.2 mole of nitrogen. So I have 0.2 divided by the total number of mole is 0.2 plus 0.2 plus 0.3. So everything will give you 0.7. Then times, then the total pressure he said is 2.10. So you now have, if you do everything, you're going to have 0.6 atm. So that is that. Okay. The next question. Right. The next question said a gaseous mixture, a gaseous mixture, a gaseous mixture of 80.0 gram of hydrogen and 56.0 gram of nitrogen has a total pressure of 1.8 atm. You now say calculate the partial pressure of oxygen in the mixture. Okay. Sorry, they said 80 gram of oxygen, not hydrogen. 80 gram of oxygen. Okay. So what do we do now? Solution. We know that the number of mole is what? Mass over molar mass. So which is what? The number of mole of oxygen is equal to what? The mass of oxygen is 80 divided by the molar mass of oxygen is 32. I hope you know 2 into 16. 2 into 16. So which is equal to what? 80 divided by 32. And 80 divided by 32 will give you 2.5 mole. Okay, so the number of mole of the next one, nitrogen, Ne2, is equal to what? Mass of nitrogen is 56 divided by the molar mass, that is 2 into 14. Okay, which is give you 56 divided by 28. So 56 divided by 28 will give you 56 divided by 28 will give you 2. That is 2 mole. Okay, so we now know that the partial pressure of oxygen is equal to N of oxygen all over what? N total times the total pressure, P total. So we now have that what? We now have that what? P of O2 is equal to what? 2.5 all over. The total is 2.5 plus this, which will give you 4.5 times the total is 1.8. So if you now do that, you will now get 1 atm. Okay, 1 atm. Okay, so that is that. So we're going to solve the last question here, and then we are done for this particular this thing. Okay, I'm going to give it as an assignment anyways. Let me give it as an assignment. Okay, they said that a 10.0 dm cube flask contains 0.2 mole of methane, comma 0.3 mole of hydrogen, okay, and 0.4 mole of nitrogen at 25 degrees Celsius. Okay, they now said we should calculate a calculate the pressure in atm inside the flask. B, say calculate the partial pressure of each component of the mixture. Okay, So that is that for that. So thank you very much for watching. In our next video, we'll now talk about derivation from gas law. Bye bye. Share, like, and subscribe.